Good evening, ladies and gentlemen. I hope you all had a pleasant Labor Day weekend. I want to thank my wife for doing the filming today, and welcome back into the Burkowski household. Now, when we last spoke, I showed you a video on basically change of state and second law of thermodynamics and how it related to making ice cream. And just as a quick reminder, if you recall, during the video, we had exothermic and endothermic reactions. You had basically the cream giving off heat, which is exothermic. You had the ice absorbing the energy, which was basically endothermic, and all of that was following the second law of thermodynamics, meaning it went from high energy to low energy. Now, what you're going to learn in the next chapter is actually about the second law of thermodynamics and thermodynamics in general, and how the second law relates to what we call entropy, okay? And the last concept that I'm going to show you today is adiabatic processes, okay? Now, if you recall, the word thermo, again, just means heat energy. A thermal or thermo refers to heat energy. Okay. Now, the second law of thermodynamics, if you look it up in a book or whatnot, it's going to define it as going something that goes from high entropy to low entropy and only in that direction, and that basically everything will continue to go towards higher and higher entropy if it's not interrupted. And so what's happening is the term entropy itself simply means disorder. Okay. Now, the way it relates to thermal energy is the faster the particles are moving, the more chaotic they are, and therefore they're going through higher entropy. So, for example, if you have energy entering an ice cube, those particles begin to start to slowly move faster and faster and become a liquid. If you continue to add energy into that, it's going to continue to move faster and faster and randomly and spread out, and that becomes a gas. So anything with high energy is considered high entropy. So if we go back to that video, you can think about it. The cream had higher energy and therefore higher entropy, okay? And the ice had lower energy and therefore lower entropy. So the second law of thermodynamics is just talking about how it moves from high energy to low energy, but it uses this term entropy. Now, you're gonna see a video later on today that talks about thermodynamics. And one of the things that is mentioned in the video is basically entropy. And he describes it as random chaos or disorder. And a common example, and one that's used in the video, is that if you have a room and it continues to get messier and messier and you never clean it up, it's going into more and more chaos and more disorder per se, and they call that entropy. Now, it's a very simple way of describing entropy, but it's not completely accurate. It's a very basic description. Later on in the week, you're going to see a little bit more detail about entropy and how it actually takes place. But again, for our purposes, guys, just understand that it relates to the second law of thermodynamics, and that you simply are going from substances will always move their energy from something that's high entropy or high energy to a substance of lower entropy or lower energy. So if I were to kind of give you a visual of that, guys, it might look something like this. Now, I draw pretty crudely, but that's okay. So I'm going to draw two circles on this board, okay? And in one circle, the one on the left, it's going to represent a solid. The one on the right is going to represent a liquid, kind of like we used in ice cream, okay? Now, the particles in a solid, like an ice cube, line up fairly consistently, and they don't move around very often. The particles in a liquid, they could slide past each other, has higher energy, tend to not really line up as much. They're a little bit more random, and the energy is moving around. So if you were to take a snapshot, in a sense, a solid would be more orderly set up, and a liquid would be a little bit less order, okay? Now, if we continue to add energy into this liquid, then the particles will be moving apart even further and faster and go through what we call higher entropy, okay? So that's kind of really how the second law of thermodynamics and entropy are connected, all right? Now, the last concept that I want to describe for you today is adiabatic processes. Now, it sounds like a fancy word, but adiabatic really simply means without heat. So you have something that actually gets warmer or cooler, gaining or losing thermal energy without heat ever being added into the system, which is very different than what we're used to. So if you took basically a frying pan and I turned on the flame on this stove and I put an ice cube in that frying pan, by adding heat to it, you know it's going to turn into a liquid. You know it's going to eventually turn into a gas and vapor, and that kind of follows that second law of thermodynamics and entropy. Well, sometimes there is no heat in the system at all, and things do cool off. So I'm going to show you a very simple example, and I'm going to use something that's right here in our valley, the San Jacinto Mountains, and we'll go with Idlewild. If you're looking in that direction, this is my mountain range, my beautiful mountain range, ladies and gentlemen, you actually will have water vapor moving towards the mountains. Now you can't see the water vapor because it's in the air, okay? But it's there in the form of a gas. So you have water vapor moving towards the mountain, okay? And what happens is once it reaches the mountain, it's forced to go up. So sometimes if you look at the mountains, basically you'll see little pockets of clouds along the side, okay? And a lot of times you'll see clouds above the mountain. It almost forms like a cap, okay? And the reason why it happens is simply this. When you go higher up in altitude or elevation, you have less air pressure. So there's less air pushing down on you, okay? If you're down here, you're going to have high air pressure, down at sea level, whatever you want to call it. If you're up here on a mountain, you're going to have much less because there's simply less air on top of you, less air pressure. So as this water vapor moves towards the top of the mountain, what happens is since there's less pressure pushing on it, the particles simply move away from each other, okay? And when they do that, they cool off. Now the individual them particles, as they cool off, they start to actually cling to each other. If they cling enough, what you simply have is rain or snow. Okay, so as it moves up, you form these puffy, cute little things, which I don't draw very well, which almost looks like my mountain range, but you form a cloud, okay? Again, because the particles are moving further away from each other because there's less air pressure, and then they will condense because they're cool, and they will form raindrops or snow or whatever the case may be. Now again, there's no heat that entered the system. It's simply spread out and cooled off because there's less air pressure. Now, as it moves over the mountain and then down the other side, the opposite happens. So now you have, as you move down the mountain, you have greater air pressure. So it's forcing those particles back together. And when it forces those particles back together, they heat up. And when they heat up, they go back from a liquid or rain that's forming in a cloud back into water vapor back on the other side. Look at this, I can even write upside down. Okay, so you have water vapor back here. So as you can see, guys, you had adiabatic heating here. Sorry, excuse me, adiabatic cooling, I apologize because of less air pressure. Adiabatic cooling, okay? And then as you have greater air pressure on the other side of the mountain, you get, oops, I think this is tilted, you might not be able to see it, so let me fix that for you. You have your adiabatic basically cooling up here where the clouds form, and you have your adiabatic heating, again, adiabatic process without heat. Nobody put any heat into the system. It just either spread out and cooled off or it condensed and heated up. And that's how clouds form and then dissipate over time. All right, so on that note, guys, I talked to you a little bit more about thermodynamics, I talked to you about entropy, and I talked to you about adiabatic processes, both heating and cooling. On that note, ladies and gentlemen, this video is now done. You have yourselves a wonderful day. Enjoy the thermodynamics video, and I will talk to you in a day or so. Have a wonderful day. Bye-bye.